Okay, this is the question on page 5 of the provincial package number 2. Uh, so you're given one circuit, it's called a circuit 1, and then if you add one more resistor, it's called R to here in parallel with R1, and then you form the circuit 2. So if you compare these two circuits, of course, you made some change to it. And then question asking for how do the voltmeter readings change? There's two voltmeters connected to the circuits V1 and V1, V2 are both of the circuits. After you added R2, you need to figure out how the current changes, and then in turn how the voltage changes of the and then you can figure out the question. Okay, let's look at this. If we have a current, so let's call it I, and then we have a current on the circuit 2, we call it I1, and see how it changes. Okay, first of all, look at this. If you add the R here, so this group, if you group them together because they're in parallel, so the equivalent resistance is going to be smaller than the original R1, right? So basically, yeah, let me put the this two the R, and okay, let's put this as R0. Okay, then change the question to R0. That will be easy to explain. So the R0 and 1 basically the combined or the equivalent resistance of these two should be smaller than R1. So what does that mean? That means if you added this R01 then R2 and add to the internal resistance altogether, the total resistance dropped. So basically the R total dropped. Let's put it this symbol means decreased. And then you can see the I1, because I1 equals the EMF divided by the total resistance, and then this one must increase. Okay, now if this one increased, and look at the V2, so the V2 equals I1 multiply R2, right? So R2 is still the same. I1 increased compared to the I, and then this one must increase as well. Okay, so we figured it right away. So the voltmeter 2, that means the V2 is going to be increased. Okay, now let's figure out the V1. Okay, so V1, as we learned about the terminal voltage, it is the terminal voltage across the battery here. So the V1 is actually the terminal voltage. It equals the EMF minus I1 R. Okay, and then if you compare it to the circuit 1, same formula, but it's I different. So the I1 is greater than the I. So since you subtract something greater, and of course as a total, this one is going to drop. Okay, so the answer is voltmeter 1 means the V1 is going to decrease. Okay, some people might stuck with this. actually the question, if the question asking for what is the current on the R1, and then because they try to figure out the V1 is actually V1 of course equals the EMF minus I1R, like we already did, but the V1 is also the voltage drop on R1 plus R2. Okay, so if you try to figure out, oh, how would this voltage change here, so we're gonna have a little bit problem. So if you look at the V2, we already figured out it's increasing. But the R, how about the R1, R0, and because altogether the current increased, but the combined resistance rises. So one decrease, one increase. So what about the voltage here? So it's kind of indeterminate. We can't really tell if the voltage on the R1 increased or decreased, right? So this is for this type of questions like this, you have to go around. Now in this case, we figure out the V1 decreased by analyzing the terminal voltage, right? But if in some other case, uh, like if it's a question asking for what is the voltage here, you can't really tell in this case, depending on other factors that's we are not certain to know. Okay, so uh, just the general rule is you only uh, try to understand what you know, and sometimes you go around to figure out something else to help you determine the answers. Okay.